Along the Dutch coastline, an ecological crisis is hiding beneath a lush green surface. 70% of the plant life here is at risk of disappearing completely because of a syndrome known as ecological freezing. The once dynamic dunes have been locked beneath a thick layer of grass, causing the entire system to stop functioning and gradually lose its biological color. For 40 years, millions of euros were poured into excavators and industrial equipment to reopen the ground, but every mechanical effort failed. When all hope was fading, scientists carried out an experiment considered insane. They released 3 bison into this coastal sand landscape and left them to survive on their own, without supplemental feeding even during the harshest winter. Everyone was skeptical, because until then, bison were believed to live only in dense forests, not on coastal sand dunes. And yet, something miraculous happened. Simply by kneeling down and rolling in the sand, these giant animals restarted a crucial physical process, helping this land recover from ruin. What was truly destroying this landscape that even millions of euros could not save? And most importantly, why could the rolling behavior of a single bison have the power to restore an entire ecosystem? The coastal dune belt of the Netherlands is not just an ordinary stretch of sand. This area functions as a giant freshwater filter, supplying clean drinking water to millions of people, while also serving as a natural fortress against waves from the North Sea. It was once home to 70% of the country's endemic plant life. But for decades, a large-scale ecological crisis has been silently destroying this place. The explosion of industrial and agricultural emissions brought large amounts of nitrogen deposition onto the dunes. Originally a nutrient-poor environment, this sudden increase in nitrogen turned the dunes into fertile ground for coarse grasses and invasive shrubs, especially sea buckthorn. They grew explosively, sending down deep roots and weaving into a dense network that completely took over the sand surface. This cover blocked the effects of wind. The dunes stopped moving. A series of specialized species that need bare sand to survive, from burrowing bees and sand lizards to pioneer plants, quickly lost their habitat and faced the risk of disappearing forever. Even worse, the shrub layer drained precious groundwater, threatening water security. The water company PWN, which is responsible for managing this area, had to spend millions of dollars every year on intervention. Dozens of tractors, large excavators, and manual clearing teams were deployed continuously to remove the invasive vegetation. But machinery created another consequence. Heavy tracks crushed and compacted the soil structure, destroying the looseness that sand needs. Moreover, the recovery speed of the invasive vegetation always exceeded the speed of human and mechanical clearing. Thousands of hectares of coastline continued to degrade. The powerlessness of mechanized technology forced managers to search for a solution never before attempted in the history of wildlife conservation. The idea was to release a giant creature into the area to create constant physical disturbance. Managers at PWN and the organization ARK Nature chose the European bison, Bison bonusus, the largest land animal on the continent. To begin the campaign, 3 bison, 2 females and 1 male, were brought into the 330-hectare Kraansvlak reserve. Immediately, the international scientific community reacted strongly. Since this animal had been saved from extinction during its most serious decline in the ancient Białowieża forest in Poland, every textbook had recorded the bison as a creature of dense forests. Releasing them into an open, windy, dry coastal dune area was considered an act with no scientific basis. The harshest condition, and also the most controversial part of the project, was the principle of non-intervention. Every previous project in Europe had provided hay or supplemental food for bison during winter, but at Kraansvlak, the rule was 0. No supplemental food, no protective measures. If they could not find enough food on their own, the project would fail. Faced with a harsh winter covering this barren area, would you choose to break the rule and bring food to save these giant animals, or firmly let them face natural selection? Leave your comment below, because this strict decision by the scientists became the turning point that shaped the entire ecological structure afterward. Their commitment to the non-intervention rule forced the three bison to reveal their most ancient survival instincts. The way they manipulated the environment triggered a chain of physical reactions that no machine could replicate. The three bison immediately became biological machines, reshaping the landscape with astonishing precision and power. Each adult consumes up to 30 to 40 kilograms of biomass every day. Imagine this enormous amount of work being maintained continuously, 24/7, 365 days a year, without fossil fuel or maintenance costs. To measure this impact, the PWN and ARK nature expert teams launched a high-tech monitoring campaign using drones with 3D LiDAR laser scanning and thermal sensor cameras. Through this, the destructive power of this army was mapped precisely in real time, and what the monitoring system recorded revealed three perfect tilling mechanisms. The first was wallowing behavior, used to remove parasites and regulate body temperature. These nearly 1-ton animals repeatedly dropped themselves into the sand, rolled around, and used their horns to dig into the ground. This crushing action broke the roots of invasive vegetation and created exposed sand pits. Unlike excavator tracks that compact the soil, disturbance from bison keeps the sand loose. Immediately, wind entered these depressions, lifting sand and carrying it farther away, expanding areas of bare sand and restarting the formation of dynamic dune blowouts that had been stalled for 40 years. After only 3 years, the dunes began moving again with each storm, breaking apart the rigid cover. Their second weapon was a strategy of destroying invasive vegetation. In winter, when grass was scarce, the bison used their teeth and horns to strip the bark from sea buckthorn shrubs, the very plants that had been choking the dunes. The stripped shrubs dried out and died, leaving thousands of broken branches as rotting wood, a food source for countless beetles. The final piece was their movement and grazing behavior. The bison moved continuously across 330 hectares along random routes, creating differences in vegetation density. They trampled the most overgrown grass areas, leaving behind a mosaic of high and low vegetation strips. Their dung and urine became organic fertilizer distributed extremely evenly, instead of concentrating and disrupting the soil's chemical structure like nitrogen from the air. This disturbance not only helped the bison survive spectacularly through the first winters, but also created a recovery loop so fast that scientists had to rewrite the entire theory. When the first winter passed, the three bison were still completely healthy. The very next year, the first calf was born. This milestone proved that coastal dunes were not a harsh boundary, but a perfect habitat. Today, the population has reached 25 animals, healthy through all 4 seasons without nutritional intervention. Analysis of their dung showed that more than 65% of their diet consisted of coarse grasses and invasive shrubs. They are the largest-scale biological disposal machine for harmful plant species. In the sand pits, a biological explosion occurred because of surface temperature differences. Bare sand not covered by grass absorbed intense solar radiation, raising temperatures in the depressions by 5 to 10 degrees Celsius above the surrounding area. Rare pioneer plants, which could not grow through the thick grass layer before, now germinated strongly along the edges of the newly disturbed sand wetlands. A clear example is the dune pansy, a critically endangered plant, which automatically returned from seeds that had been dormant underground for decades. The bare sand, heated quickly by the sun, soon attracted sand lizards migrating in to bask and lay eggs. A series of specialized insects that need open space to dig burrows, such as sand bees, also returned in dense numbers. In addition, the massive volume of nutrient-rich organic dung from the bison awakened the return of dung beetles. This explosion then attracted rare predatory birds such as the red-backed shrike, completing the closed food web. This project completely changed the landscape of conservation in Europe. A paper published in the scientific journal Regeneration Ecology after a decade of research acknowledged an overturned truth: bison are not limited to dense forests. In reality, they were always builders of semi-open landscapes. Their retreat into dense forest in the previous era happened only because they were hunted by humans. But turning a giant wild animal into a tool for managing natural infrastructure is not a campaign without a dark side. Harnessing the power of nature always comes with limits and a very high price. Deploying a bison population in a shrunken landscape is not the same as buying a fleet of excavators. The biggest barrier of this model lies in managing spatial conflict to make sure these one-ton animals do not wander into residential areas or highways. PWN had to establish a high-strength electric fence system around the entire 330-hectare area. The cost of fencing, along with GPS collars attached to leading individuals and a continuously operating security monitoring team, consumed a massive budget in the early years. This solution cannot be applied carelessly anywhere. It requires a large enough buffer zone and absolute agreement from the local community. Moreover, bison are not machines that can operate forever without genetic maintenance. The entire European bison population today descends from 12 individuals that survived the species near extinction. This genetic bottleneck is a major hidden risk. To prevent the Kraansvlak population from suffering biological decline due to inbreeding, managers are forced to carry out costly transport campaigns, continuously exchanging bison between the Netherlands and reserves in Poland and Spain to mix genetic lines. Many reports praise this as a model of hope, but independent survey data from ecologists points to the risk of carrying capacity limits. The 330-hectare space is too narrow. When the herd reaches its peak, it may overgraze the very rare vegetation that has just recovered. To avoid this risk, managers will have to intervene artificially through periodic culling or by relocating surplus individuals, turning the ecosystem into a loop dependent on humans instead of one that is fully wild. This has ignited sharp ethical criticism in academic circles. Are we conserving wildness or creating a survival labor force? The bison are kept behind electric fences, tracked by GPS, and made to till the landscape according to a planning agenda in order to protect groundwater systems for humans. Turning an endangered creature into an unpaid garbage cleaning machine inside an open-air glass cage raises a major question. Is this truly a humane model of natural restoration, or only a sophisticated form of ecological exploitation under the name of conservation? However, despite the ethical paradoxes and the enormous cost problem, once this intervention system entered its trajectory, it forced us to rethink how humans should treat degraded ecosystems. The data from Kraansvlak does not stop at the Dutch border. It has sparked a revolution in ecological planning across Europe. Countries that once completely excluded coastal areas or open grasslands from bison reintroduction lists are now rushing to reassess them. As this idea spread strongly, the United Kingdom applied the model at the Wilderness project in Kent, releasing bison into heavily invaded areas. Switzerland and Spain have also begun launching similar campaigns to restore land structure. Policymakers realized that although machines can cut thousands of tons of shrubs every day, they can never create the complex networks of microhabitats produced by a 1,000-kilogram animal rolling in the sand. The story of the 3 bison at Kraansvlak offers a large-scale lesson in ecological risk management. For decades, humans have tried to use industrial power, mechanization, and massive streams of funding to deal with environmental change. We built bigger and bigger machines, only to realize that ecosystems were still continuing to collapse. The real solution, capable of operating across thousands of hectares with century-long sustainability, does not lie in adding more artificial technology into nature. It lies in understanding which biological links have been broken, returning the right ancient ecological engineers to their proper positions, and having enough courage to step back and make room for the power of wildness to operate on its own. If you are impressed by the way nature restores itself and want to continue decoding large-scale intervention projects that change the course of the world, press like, share this video, and subscribe to the channel right now so you do not miss the next in-depth analyses.